Now this second part of this video of the Inventec's motherboards, the new generations laptops, okay, and how the power flows inside in the laptop, and what are the test point we have to see, that we'll see in this video. Okay, so see, uh, this laptops have the two power inputs. One is a type C and another is an adapter. Then there is a buck boost converter which generate the next voltage, that is a 12 volt, that is a PV bat voltage. You can see here in this you can see here this is a PV bat voltage. Okay, so this is a PV bat voltage. From adapter it's going to PV bat voltage, and here are the different buck converters uh, generate a different volt, but within that there is a one voltage will generate first, that is a 3 volt and the 5 volt. Okay, so what we'll do, we'll go to the 3 volt and 5 volt section, because SIOs require a 3.3 volt to turn on, because in any laptop the first chips which is going to turn on, and that chip is called the SIO. SIO needs the power, that is a 3.3 volt. Okay, so for that that particular buck converter should be turned on before power on button press. That is a requirement of any laptops. Okay, so for that we go first the 3.3 volt section, that is, we'll scroll down this and we'll see where is that sections. Yes, that is this section. Now you will ask how you'll find this is a 3.3 volt. So you can you can zoom this diagram, then we can see here is the mention P3V3, P3V3, 3.3 voltage. Okay, and here in the index page also you can see in bottom side there is a index page, the mention the Inventec before the model numbers and all things are given, and here you can see this P3V3DS, that is a 3.3 voltage, and we are on page number 11. So here is a the single chip buck converter. So in previous model on the older laptop, the 3.3 volt and the 5 volt section is a combined, that is on a single chips. But nowadays the new generation laptops coming up with the separate 3.3 and 5 volt section. So in this models, the 3 volt and 5 volt section is a different. This is a single chip buck converter. There is no MOSFET you will see in this laptop. The MOSFET are also merged into this chips. Okay, so here is this chips 3 which generate a 3.3. We'll zoom this chips. We'll zoom this chip and you can see the chip location is U60100, and the chip number is NB680. Okay, GB. So this is the chip, and this chip is a total this is a 12 pin chips. Okay, so now this chip is a VIN, this pin is a VIN. So this is a VIN, and here at this pin the 12 volt will enter into the chips. Okay, voltage inputs uh, in this chips U6010. Okay, so you have to check that, and then what happen is this chip will generate a linear voltage, that is LDO, low drop output. The 3 volt is coming out from here, 3 volt is coming out from here, and that voltage is called VRP3V3A underscore LDO. So here will be 3.3 volts. So this is the first step. Now if you see, if you have a laptop and you can see if the 12 volt is entering into the chips, but at pin number 6 3.3 volt is not coming, then you have to replace this chip. This chip is faulty, so you have to check in this way. So now the next thing is where this 3.3 volt is going, this particular voltage is going. So we'll see that. So we'll select this signal, we'll copy, we'll come here, cancel the previous data, and then we'll paste it here. Click on next, then next, and and then you can see this signal this signal 3.3 volt signal is going here, cross this resistor, and then that signal name will be changed, that is a en underscore phi underscore 3v. So this is a enable signal is going to the page number 28, page number 75, and page number 79. Okay, so this enable signal is coming out. So we'll see where this signal is going. For that, we'll cancel this, copy, remove the previous data in the file, paste it, next, and this signal is going to the individual 3.3 and 5 volt enable. You can see this, in this way the schematic you have to trace. Okay, this is tracing is very important when you are tracing the motherboard. So you have to understand the concept. First you should figure out which chip should be turned on. Like in any laptop, your SIO should be turned on, and the SIO need a 3.3 volt. The newer generation, of course, some models require a 1.8 volt also, but now most of the SIO work on 3.3 volt, and that 3 volt is generated by the 3.3 volt buck converter. So, and that buck converter require enable signal. So now this en underscore 5e underscore 3v is divided into two parts. This signal is divided into two parts, and here is the generate enable 5 volt and enable 3 volt. So we'll leave this 5 volt. We'll first select this signal where this signal is going, en underscore 3v. So we'll remove this, we'll paste this, and the next, and you can see we come back again to the same page where we start, the page number 11, where the 3.3 volt is generated. See, this buck converter have a two department. One is a linear regulator and another is a buck converter. This linear regulator voltage is coming out from this pin LDO. This 3.3 volt is coming out from this pin, pin number 6. When he receive pin number receive 12 volt from pin number 1. So this is the input and this is the output, right? So this output is called a linear voltage. It's called the LDO, low drop output. LDO stands for low drop output. Normally it's given to the SRO. But here is this signal is again reroute, and this signal is now is given enable to this, it's going to the pin number 11, and once the chips get the enable, start the internal buck converter, generate the pulsating AC voltage, and then pass to this coil and filtered by this all the capacitor, and here the 3.3 volt will be generated. Okay, and this 3.3 voltage is called VRP 3V3A. Okay, so this is a buck converter. So this 3.3 volt section or two outputs. One is called the linear output and another is called the buck converter output. Now this voltage is going to the SIO in this particular model. Normally in most of the laptop this 3.3 voltage is going to the SIO, but in this model this 3.3 volt is coming. So before power on button you should get a 3.3 volt here, and the 5 volt and the 1.8 voltage, because this 3.3, 5 and 1.8 generate before power on button press. Okay, so you have to see that. Okay, now if all three voltages are coming, then we have to go to the SIO. So SIO is on page number 65. So we'll go in the page number 65. So here is my SIO. The SIO's location is U300, and the SIO, the number is a Neoton SIO, and the number is NPC X797HA1BX. So this is my SIO number, and that 3 volt which is generated by the buck converter which entered into this chip. So see, here is the 3.3 volt, and this 3.3 volt is entered into here, and then here different pins. So here this all are the pin number. So you have to check the 3.3 volt coming to this particular chips. So once the chips get the 3.3 volt power, then it's ready to work. Then you have to check rest of the signal. You have to check this power button, adapter detect, and then there must be two power button. We'll see where is another power button. So this SIO is basically divided into two parts. One part is here and another part is here on the next page, page number 66. So we'll zoom it and we'll see where is my power button. So this is Amber LED caps, power standby, DPWR, okay. Then this is RSM RST, this is KBC power on, okay. This is a power button, okay. So this is a power button. So what we'll do, we'll confirm whether this is a power button or not. So before that, we'll see any other power buttons are there or not. Yeah, this is a power button out. This is going to the, we'll see the first this where this thing. See, there are two power button. One power button is the input power button which a user press. Okay. Another power is the power button is the output power button which generated by the SIO and sent to the CPU. Okay. So here are the two power buttons. So what we'll do, if this is the output power button, that must going to the CPU. So what we'll do first, we'll see whether it is going to the CPU or not. So we'll select this signal. We'll copy this signal. It's going to the page number 38 and 65. So we'll cancel the previous signal. We'll paste here and then we'll click the next. Then next. Yeah, the next. It is going here. It is going here. And what is this? We'll see. So we'll go down and we'll see on index. And this is MCP2 SPI. Okay, so this is yeah, this is the CPU. Okay, it's called the SoC. You can see, so this is the CPU. This is the output power button and which generate by the SIO and sending to the CPU. So this signal is a 303 pulse. It's not a straight 3 volt. Okay, so once you press a power button, then what you have to do is you have to uh, connect your multimeter at this particular pin. So now in this particular model, the both chips are the BGA chips. Okay, so SI also BGA and the CPU also BGA. So you cannot check on that pin. So for that you have to use a board weaver, and from that board weaver there is a signal, the same signal, that power button out signal, and that signal you have to connect the multimeter and you have to press the power button. Once you press the power button, here your 303 pulse will be generated. 303 pulse will be generated, and this 303 pulse is generating, and that means your SIO is functioning. SIO is sending this power button out signal. Okay, so now this signal, now we are confirmed this is the output signal. So we'll go back to the SIO. Yeah, we go back, we come back in page number 66. So we'll come here. Where is the another power button? Oh, this is the power. Okay, standby power. Yeah, this is a power. So what we'll do, we'll select this signal here, KBC underscore PWR underscore on. So we'll select this, we'll copy this signal, come back here, remove previous data, paste new data, next, then next, then next, and then next, then next. Yeah. Okay, this is not the power button. Okay, we'll go up and we'll see in here power button signal, power on off switch or the power button. The name will be there. So here is one more power button in page number 65. So what we'll do, we'll select this signal, power button, copy, come here, paste it, Click the next. Yes, this is the power button, right? It's going to page number 65. This is the power button, power switch, and this is the input power button. Okay, so this input power button, it generate, the user press this power button, and this signal is going to the SIO, and then the SIO out this power button output to the CPU. Now, if this power button is not, once you press the power button, 303 pulse will be generated, but you won't get a power button out signal uh, from your SIO. That means, so what to do at that time? What you have to do is you have to check, the next signal is called the RSM RST. So what you have to do is you have to select here RSM RST. This is a very important signal. If your laptop is not powering on, and you will find that the output power, once I press the power button, but still my uh, power button out signal is not coming, then what you have to do is you have to you have to check this signal. See, the pin number is M10. So here will be generated 3 volt. So at the when the laptop is off state, there will be 0 volt, but once you press the power button, you have to check this signal should be a 3 volt, and if the 3 volt is not coming here at this point, that means SIO is not turning on the laptops, not turning on the power. So for that, what you have to do, you have to check AC in signal, you have to check lead switch, and you have to check if the EC bias is there, then you have to flash the EC bias, or the last, if you check everything but still the RSM is not generating after pressing a power button, then that means your SIO is bad. So you have to replace the SIO. So in this way, friend, you have to see the fault finding. Now, if the power button out signal is coming, but still there is no output, in that case, you have to check the next signal, and that signal is called the SLP S3 and SLP S4. SLP S4 and SLP. You can check any of the signal, SLP S3 or SLP S4, and this both signal generated by, who generate this two both signal? This both signal generated by the CPU. Okay, so you can check anywhere this signal is coming, is going to the so many places, so you can check this signal anywhere, but this main source of the signal, this SLP S3 and SLP S4, here are three SLP 3, SLP4 and SLP5. SLP5 basically turn on 3.3 and 5 voltage, SLP4 basically turn on the DDR supply, and SLP3 turn on the PCH supply. And when all signals are there, that means your CPU core voltage and the graphics core voltage will be turned on. So the laptop is fully on. If all three signals are present, then your laptop is fully on state. So it's like that. So we'll see this signal. Yeah, you can see this signal. So this is a CPU, and here you can see at this pin, BJ37, BJ36 and BU27, BT29, these three signal generated by the CPU. It's called SLPS3, SLPS4 and SLPS5 after you're pressing the power button. Now if this signals are not coming, then the CPU is not responding. So in that case, so you have to check uh, RTC reset and RTC VCC. You have to check both the signal, RTC reset and RTC VCC, and you have to check DPWR signal. You have to check DP if this signal is not coming. Okay, SLPS3 and SLPS4 is not coming, but RSM RST coming and PM power button out is coming. Then you have to check DPWR. Okay, like this signal. Okay, so you have to check this signal. If the DPWR okay coming, then the next signal you have to check VCC SUS signal. The VCC SUS is basically a supply. There is not VCC SUS, but it's a power to the it's a power to the PCH. So you have to check this power. Okay, and if all the things are coming, but still the SLP3 and SLP4 signal is not coming, in that case the CPU is bad. So you have to replace. But before replacing the CPU, you have to check RTC clock. Okay, so RTC clock, how you will check RTC clock? With the help of multimeter. You just, sorry, with the help of oscilloscope. Take an oscilloscope and check 32.7 kilohertz frequency at the RTC. If the RTC is not coming, then replace the RTC crystal, your problem will be solved. But if the RTC crystal is not generating the frequency, replace the crystal. After replacing the crystal and all the voltages are also proper, RTC reset also proper, PM power button also coming, RSM RST also coming, VCC DSW also coming, everything is coming, but still SLP S3 and SLP S4 signal not generating by the CPU, then in that case you have to replace the CPU. So friend, in this way you have to diagnose the problem if the laptop is not powering on. Okay, so thank you very much.